Hi everyone, we're going to go through the scientific notation notes. So you should all be on this slide in your Unit 1 digital notebook. It looks like this, and it is the very first slide, or I guess the second one after your agenda slide that says Day 9. So make sure you are here, and we are going to go ahead and get started. So the first thing I'd like you to do is in this top section is to hit pause already and work through these problems. You've got some multiplication problems. You're going to try and solve these. 1.5 times 10 to the 5, so on and so forth. Yeah, so hit pause now and see if you can get those numbers real quick. Okay, welcome back. Let's take a look at what our calculator shows us when we type these math problems in. So 1.5 times 10 to the 5 will give us 150,000. 9.999 times 10 to the 4th gives us 99,990. 9.8 times 10 to the negative 6 gives us 0.000098. And then 7.13 times 10 to the negative 3 gives us 0.00713. So these are all math problems. Oddly enough, the multiplication problems that you just saw, that you just worked out, have a very specific format known as scientific notation. And that is a mathematical expression that we use to represent a decimal number between 1 and 10, right? And it's multiplied by 10. And we do this. The reason we use scientific notation is so that we can write large numbers using less digits. So long numbers, things that have a lot of things to write, numbers that have a lot of things to write, we want to write them with less digits. It takes less time. And it's also useful when you need to round numbers with lots of digits, scientific notation. So to change numbers from standard notation, which we can also call expanded form, and this is what we're used to seeing all the numbers laid out in front of us. So to change from standard form to scientific notation, all you have to do is move the decimal from the left or to the left or right. So the goal is to place the decimal, and this is important, between the first and second non-zero digits. Okay, so anything that's not a zero, it needs to go between the first and second one of those. There should only be one number on the left of the decimal, meaning 1, 2, 3, 4, 5, 6, 7, 8, or 9. So one single digit number on the left of the decimal. So the direction that you move the decimal and the number of places that you move the decimal determines the sign and the size of the exponent. So here's a quick visual. Here's the number 5,785. The decimal is right here at the end. We move it 3 places so that it's between the first and second non-zero digits, so that there's only one number on the left of the decimal. So right there. We moved it 2 places, and so it gets a positive 3 exponent. This other number, we moved it 4 times, the decimal 4 times, to get between the first 2 non-zero digits. So 7.4, and our exponent is 4 this time, but notice it's negative 4. And we can talk about left and right, moving left and right, but I think what's more useful is thinking about the size of these numbers. 5,785 is a huge number, so we have a positive exponent. 0.00074 is a tiny number, so we have negative exponents. And so there's a notice here. You can complete the multiplication of this scientific notation number, and it will give you the standard form. So your calculator is your best friend here. So if you type that in, 7.4 times 10 to the power of negative 4, you're going to get this number. If you type in this scientific notation, you'll get that number.